This lesson is about finding the length of a chord. Now, first of all, probably helps to know exactly what a chord is. And within a circle, if we draw an internal angle, we'll call that theta, and you look at the distance from the points of intersection of the circumference of the circle. And you want the straight line distance. Remember, arc length was this distance around the outside edge. That was pretty easy to calculate. In terms of radians, it's just the angle times the radius would give you this arc length. But this straight line distance is a little different. But it's not that hard to calculate. There's a simple formula, and the formula can be derived rather quickly. Again, I would caution against just trying to memorize the formula. Instead, think about what you've got, what you know, and then we'll come up with how to derive this formula on the fly. That'll help you down the road. You're more likely to memorize it or remember it when you need it. So let's take a look at what we got. We got some angle in here, and we got some radius here, which happens to be the same up here. And what you're making, essentially, is an isosceles triangle. Now, we don't know that any of these angles happen to be 90 degrees. If they did, it'd be a pretty easy trigonometric identity to figure out what the length was. So what we're going to do is we're going to bisect that angle, and we're going to intersect this base down here, and we're essentially going to force this to have a right angle in it. So we basically draw our height line, and then we know for sure this is a right angle. We've got an angle here that is actually half of what the original angle was. We bisected that angle, so it's half as big as it used to be. So now we have an angle here. We easily calculate by dividing by 2. We know this distance here. Right now it's just r, but that's a distance that you would know, or at least r is a number that we can use as r. And what we want to do is we want to calculate this distance from here up to here. Now what we're going to get some value of x, and that distance is only going to be half what we need. So when we get that, we're just going to double it. That's easy enough to do when we're done. So if we can get half of it, we've got the answer. So let's take a look at trig here. I know this value for my hypotenuse. I'm interested in the opposite side of the angle. Well, the opposite over the hypotenuse is the sine. So I can just simply write down that the sine of theta over 2 that's this angle right here. Remember, it's half the total. The sine of theta over 2 is nothing more than x over r. I can reduce this to x, or solve it for x, by simply multiplying both sides by r. So if I multiply this side by r, and I multiply this side by r, then I'm going to get r times the sine of theta over 2 is equal to, these r's cancel out, and it leaves us with x. All right, that's the distance from here to here, but remember that's only half what we want. We want this entire distance. So the entire distance is going to be twice that. So simple enough, we would say that 2 times the radius times the sine of theta over 2 is equal to our chord length. Now, it shouldn't take you very long to recreate this if you need it on a test. The best thing to do is simply recreate it once. There might be 3 problems that quiz you about chord length, but over in the margin, come up with your verified formula. If you memorize the formula, write it down somewhere, and then just double check it real quick. Make sure you've got the right formula down, that you haven't used the formula for the arc length or formula for the area of a sector of a circle or something like that. It's very easy. A lot of these things have the same components in them. The radius appears in a lot of these formulas. In this case, you're multiplying by 2. In other formulas, you might be dividing by 2. And so you want to make sure you get the right thing. Easy enough just to kind of draw this out somewhere. Remind yourself, oh yeah, this is going to be simply r times the sine of half that angle. So it's pretty easy to just verify that you've got the right thing, and it's a good thing to do. It only takes a minute or two, and then you'll have that reference in the margin of your test. You can simply use this formula. So, generally speaking, when you're talking about these half angles, you're going to end up having to use your calculator to actually calculate the sine of this value. It's unlikely if they give you an angle that half that angle is going to just happen to be one of the angles that you know the exact value of sine, cosine, tangent. So for the most part, they're going to be looking for a decimal answer here. Usually the test will specify, or you can ask your teacher during the test, do I need an exact value here, or can I do with a decimal? Another way to think of it is if I take half a theta and I get one of those angles that I know the exact value of. For instance, if theta is 60, half of 60 is 30. Well, I know the sine of 30. That's on my unit circle. So in that case, I think you'd be expected to express that as an exact value and not a decimal. And that's how you find the length of a chord, and also how you can avoid having to actually memorize the formula. Simply know how to get it when you need it.